All right, this is going to be a video going through the test review for our Unit 2, Part 1 Quadratic Functions and Equations test. So number 1 says solve the equation below. The first thing I notice is that it's a square root, so I want to get rid of that by squaring both sides. And when I do that, I get x plus 2. And I want to make sure that I multiply out x minus 4 times x minus 4 and not go to math jail. Like, do not remember x minus 4 squared is not equal to x squared minus 16. If you do this, you will be in math jail and be losing a lot of points, so don't do that. Instead, we're going to have x plus 2 equals x squared minus 4x minus 4x. This pencil is messed up. Plus 16. Okay. So now we're going to have x plus 2 equals x squared minus 4x, minus 8x plus 16. Now I'm going to subtract the x plus 2 from both sides, and I'm going to get 0 equals x squared minus 9x plus 14. And I want to see if I can factor that because that would make it easier. And sure enough, I can use negative 7 and negative 2, x minus 7, x minus 2, and I have two possible solutions, 7 and 2. And I say possible because remember, I squared both sides. So I have to go back and check. When I square, I force everything to be positive. It's possible that that isn't really the case. So first I'm going to check 7. 7 plus 2 equals 7 minus 4. Well, in DDO, that's a check. So now I'm going to check 2. The square root of 2 plus 2 equals 2 minus 4. Oh, that's a big nope, because the square root of 4 is not negative 2. So 7 gets the box of joy, 2 gets the x of shame. Moving right along. Oh, explain why you had only one solution to question number 1. You must use a graph in your explanation. So my original function was equation was the square root of x plus 2 equals x minus 4. So what I'm going to do is I'm going to graph the square root of x plus 2. So y equals. So immediately I know that that moves left 2. So my regular square root is here. I'm going to move it left 2. And now I'm going to go, and what I'm really doing, guys, is I'm thinking, I'll do it in red, I'll put the dots down. I know that this is my regular square root, like the square root of 1 is 1, the square root of 4 is 2, the square root of 9 is 3. And I'm just going to move that graph to the left 2, because that's really just the easiest thing to do. All right, and now I'm going to graph y equals x minus 4, which is like the super easiest thing ever. Y-intercept of negative 4. Slope is 1, up 1, right 1, up 1, right 1, doot, 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 doot. And sure enough, they crash into each other at x equals 7, and that's why we have one solution. So explain why. Because the graphs only cross twice, or cross once. If y equals x plus 2 crossed y equals x minus 4 at x equals 2, it would not be a function. I just totally misspelled function. Alrighty-o. And then maybe I could even be because I'm so color coordinated, I could draw the bottom half of the graph. Arrow. All right, evaluate the following expressions. So the first thing I want to do is think to myself, what is the highest power of 4 that goes into 32? And sure enough, 32 itself is a power of 4. So I know that any power of 4, just as a reminder, I to the 4th is 1. And I know this because I squared times I squared is I to the 4th. And I squared is negative 1. Negative 1 times negative 1 is positive 1. So that's 1. Letter B, I'm going to break up to I to the 80th times I to the 3rd. I know that I to the 80th is 1 And I'm going to think to myself, okay, I to the third, if I have to remember that one, that's going to be I squared times I, because I add 2 plus 1 is 3. I squared is negative 1. So I to the 80th, that's just 1. And then I to the third is negative 1i, or just negative I. Letter C, I'm going to break up I to the 14th as I to the 12th times I squared. I to the 12th is 1. I squared is negative 1. I'm going to break up I to the 21st as I to the 20th times I to the 1st. I to the 20th is 1. 1 times I is I. Provide 3 examples of each of the following numbers. So what I'm going to do when I write my examples out is I'm going to make sure that that is the most specific classification for each. So 3 irrational numbers would be my favorite root 2, my second favorite root 3, and then of course I'll give you 4 because you got to have pi and e. Pi and e are like the popular ones. Okay, so imaginary numbers, I could go with I could go negative 2i, and I'm going to do I root 5. Natural numbers, I'm just going to go 1, 2, 3. Rational numbers, I'm going to go 1/2, 1/3, and I'll get fancy on the last one with negative 7/5. Integers, okay, because I want to give that's the most specific classification, I'm going to do negative 5, negative 4, and negative 3 because I can't classify those as natural. Complex numbers, again, you really could use all of these could be considered complex numbers, but the most specific, like 4 plus I could do 5 minus 2i. I could do 1/2 plus I root 2. Real numbers, so for real numbers, there's really, like, I have to take the most specific classification is never going to be just real because all real numbers have to fall either as rational or irrational numbers. So I'm going to give a couple. I'm going to give the square root of 7. I'm going to give 1/9, and I'm going to give pi because it's fancy. Whole numbers. Again, the only number that is whose most specific classification is whole is that troublemaker 0. So I'm going to go 0, 1, 2. All right, perform the following operations. So the first problem is just an addition problem. I'm just going to add my real numbers. That gives me 1. I'm going to add my complex numbers. That's going to give me negative 11i. Letter B is a subtraction problem. So the first thing I'm going to do is distribute the negative. So I'm going to rewrite this as 3 minus 2i plus 7 minus I. And that gives me a final answer of 10 minus 3i. So now I'm going to multiply, and I'm going to distribute. You totally could box. I just don't want to. So I've got negative 6, and then I've got minus 12i plus 14i plus 28i squared. I'm immediately going to make the 28i squared negative 28 because I squared is negative 1. And now negative 28 and negative 6 become negative 34 plus 2i. All right, letter D, I'm going to pull out the I, and I've got I root 7. And then I'm going to pull out the I again, and I've got I root 3. Then I've got I squared, and I can multiply the arguments, root 21. And then finally, I squared is negative 1, so it's going to be negative root 21. And that doesn't reduce. So now these do reduce, so I'm going to make the square root of negative 4 2i. I'm going to make the square root of negative 25 5i. 2 times 5 is 10. I times I is I squared. And I've got negative 10 as my final answer. Again, letter F, I don't want to distribute the square because this is a sum, it's not a product. So I'm going to go rewrite this as 3 minus 5i, 3 minus 5i. And then I'm going to distribute, and I get 9 minus 15i minus 15i. Oh, I'm going to run a space. Plus 25i squared. Sorry, that's so messy and small. So now this becomes minus 25. 9 minus 25 would give me negative 16 minus 30i. Box of joy. All right, now this next set is probably the most important set. It says solve the quadratic under the complex number system. Choose the most efficient strategy. Solve one problem by factoring, one by completing the square, one by square roots, one by quadratic formula. You may not repeat methods. Each method may only be used once. Justify your choice of solving using the following sentence starter. Now, I am not going to write this out because honestly, I am the teacher. I will read it out and then you can pause the video if you need to use my exact wording, but really, you should be able to write the sentence on your own for most of them. Okay, so after I decide on my method, I'm going to solve the problem and I'm going to state the number of x-intercepts. I think that really just means roots, but that's okay. I'm also going to talk about if they're real, imaginary, etc. Okay, so the first thing I'm going to do as I approach number 6 is I notice it's in standard form, so that's a bonus to start. I notice that a is 1, also a bonus to start. So the first thing I want to ask myself is, does this factor? Is there anything that multiplies to 20 and adds to 4? I don't think so. Let's see, 20, 1 and 20, 2 and 10, 3 doesn't go into 20, 4 and 5, and that's it. So the answer is nope. I can't factor it. So I'm going to have to complete the square. To solve the equation, completing the square is the most efficient method. To solve the equation x squared minus 4x plus 20, the most efficient method to use is completing the square. I know this because when I analyze the structure of the equation, I notice it does not factor, and a is 1 and b is even. And that tells me completing the square is the best method. So the first thing I'm going to do to complete the square is I'm going to move the 20. So the next thing I'm going to do is I'm going to grab my b value, negative 4 divided by 2. And again, this is really the answer to b. Like, a is for your sentence, but I'm just going to use all the space for solving so I have more room to write. So I can write a little more legibly for you. b over 2 squared is 4. So I'm going to add 4 to both sides. Then I'm going to factor this. It's going to become x minus 2 squared equals negative 16. Now I'm going to take the square root. This is satisfying. I like these ones because 16 is a perfect square number. That's fun. Equals plus or minus 4i. And then for my final answer, I'm going to have x equals 2 plus or minus 4i. So I have no x-intercepts. Like this graph, if this was a graph, like if I made this y equals, I have no x-intercepts because I have 2 complex solutions. All right, number 7. The first thing I notice about number 7 that it is tragically not in standard form. So I'm going to move the 12. 2x squared minus 5x minus 12 equals 0. And I'm going to check to see if it factors. I'm not going to jump to the quadratic formula right away. That is a terrible idea. So I'm going to do 2 times negative 12 off to the side. That's negative 24. And is there anything that adds to 5 that multiplies to negative 24? Indeed, there is. I can use negative 8 and 3. So you can box or you can split. I'm actually going to do both because it doesn't take too long. My box, if I wanted to set that up, 2x squared minus 8x plus 2x. If I was going to split, and again, don't forget to write your sentence. So if I'm splitting in the middle, I'm going to take out a 2x, and I'm left with x minus 4. Then I'm going to take out a 3, and I'm also left with x minus 4. My two factors are 2x plus 3, x minus 4, equals 0. If I was using the box method, maybe I'll pick the 2x squared because obviously there's a 2 there. Oh wait, whoa, this should be a 3. Sorry. Whoopsies. So yeah, that would have been weird. So this is 2x, this is x. This is negative 8, so this has to be negative 4. This is x, this has to be a 3. And sure enough, negative 4 times 3 is negative 12. So I get the same two factors that I got from splitting the middle. When I set my factors equal to 0, I get negative 3 halves and 4. And that tells me that I have two x-intercepts because, like if this was a y equals, because there are two real solutions. All right. When I get to number 8, it's pretty basic, and I immediately know I'm using square roots because it's just x squared plus 5. There's not, all I have to do is subtract 5. Take the square root. And I have no x-intercepts because, like if this was equals y, because both solutions are pure imaginary or complex. All right, so I have, let's see, what have we done? We completed the square for number 6. We factored for number 7. We used square roots for number 8. So I bet, obviously, number 9 is probably going to be our quadratic formula. Let's get it into standard form and find out. If I subtract the 7x, I get negative 3x. If I subtract the 10, I get negative 10. If I do 2 times negative 10, I get negative 20. Nothing adds to negative 3 that multiplies to negative 20. So it is time for our old friend, the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. If you do not memorize the quadratic formula before the test, you're gonna be really sad. Here we go. So b is already a negative 3. So when I put it into the quadratic formula, I'm gonna immediately make it positive 3. B squared is 9 minus 4ac all over 2a. I should have just made that a 4. All right, so now off to the side, I'm going to take care of this argument, what's under the square root. I know that I have a negative times a negative here, like this negative 4 times 2 would be negative 8. And then negative 8 times negative 10 would be positive 80. So this is going to be 9 plus 80. So I'm going to have x equals 3 plus or minus the square root of 89 all over 4. One of the ways I know that I was efficient in my method is 89 doesn't reduce. Like if this reduces, you weren't efficient. So I have two real, so like if this was a y equals, I have two real solutions. Like they're ugly, they're irrational, but they're real. So there will be two x-intercepts. So like if I were to graph that on my calculator, I just wouldn't see it cross at nice integer values. All right, last page. Write the following quadratic in vertex form and state the vertex. So I'm going to do this by completing the square. On the quiz, I was specific it had to be completing the square. If the directions say to complete the square, you need to complete the square. If not, if you want to use negative b over 2a and then plugging that back in, you are of course free to do so, but please make sure you know how to do it by completing the square because you never know how I am with directions. Sometimes I'm particular. So I'm going to start by adding the 2. Now I'm going to think, okay, here's my b, 8. 8 divided by 2 is 4. 4 squared is 16. So now I've got y plus 18 equals x squared plus 8x plus 16. And that factors, so I've got y plus 18 equals x plus 4 squared. And then all I have to do to finish it up is subtract the 18. And I get y equals x plus 4 squared minus 18 and state the vertex. The vertex is negative 4, negative 18. Ta-da! All right, now 11 of 14 just says solve. It doesn't care how I do it, just wants me to solve. So I'm looking at number 11, and I'm hoping that none of you were thinking, oh, yay, it's factored. I'll just set them both equal to 2, because you would go to math jail so hard and like the whole question would be so wrong and I would cry big giant crocodile tears all over your test. It would be sad. Ladies and gentlemen, there's no such thing as the 2 product property. I cannot set 2 factors equal to 0 or equal to 2 and solve. What I need to do is multiply this out. You can FOIL or you can box. I'm not going to show all the work. When I multiply that out, I get x squared minus x minus 12 equals 2. Then I'm going to subtract the 2 and I get x squared minus x minus 14 equals 0. Now, there are no 2 numbers that add to -1 and multiply to -14, so I can't factor. It's not a good candidate to complete the square because b is odd. So I'm going to use the quadratic formula. X equals -b plus or minus the square root of b squared minus 4 times a times c all over 2a. So 4 times 14, 40 plus 16 is 56. So I have 1 plus 56. So my final answer is x equals 1 plus or minus the square root of 57 over 2. I'm going to pull the 3 over in number 12, get it in standard form. And I'm going to check to see if this factors. I'm going to do 6 times -3. That gives me -18. Are there 2 numbers that multiply to -18 and add to -7? Oh, yes, there are. I could do 2 and -9. All right, so if you're a boxer box, just for space, I'm going to split the middle. So 6x squared plus 2x minus 9x minus 3. Take out the 2x, I get 3x plus 1. Then I'm going to take out the -3, I get 3x plus 1 again, which is important. And my 2 factors are 2x minus 3 and 3x plus 1. So my 2 solutions are 3/2 and -1/3. Why do my 1/overs always look like y's? I don't know. All right, when I look at number 13, man, that is such a good candidate to square root. I'm just going to add the 15 to both sides. This is not sad that there's no i's yet. I hope there are some i's. X plus 4. 15. I'm going to take the square root. I'm going to write x plus 4 equals plus or minus the square root of 15. If you don't write that plus or minus, I'm going to cry in my head because I warned you. And hopefully that was the easiest problem in this set. Last but not least, number 14. I'm going to move the 7 because I like standard form. It's easier to evaluate. And as soon as I do that, I'm like, well, that was dumb because this doesn't factor. Nothing adds to 4 that multiplies to 7. And this is good to complete the square because this is 1 and this is even. So guess what, Mr. 7? You're going back to the other side with you. I'm putting you back over here where you belong. b over 2 is -2 squared is 4. Oh man, no imaginaries. I've got x minus 2 squared equals 11. And then I get x minus 2 equals plus or minus the square root of 11. And my final answer is x equals 2 plus or minus the square root of 11. Ladies and gentlemen, there's the test review.